Bismillahirrahmanirrahim. Assalamu alaikum and good day. Today I'm going to continue with another content inside our inheritance and polymorphism, which is on toString, instanceOf, and polymorphic reference. Okay, the other content has been covered in our lecture in class. All right. Now let me go straight to toString method. I think we've been using this toString method before. toString method basically is a method that we use in order to return a string of a data type. Maybe in that class there are several variables with a different type, or maybe integer, double, and so on. But in this toString method, basically we normally put those data together and convert it into a string form. Originally this toString method is actually from object class. Okay, actually from object class, and and you can actually call this a method that returns a string. Okay, it's a method that the return type is a string. There are two ways on how to call the toString method. The first one is to call the object name dot and then write the toString method, or you can write the name of the object straight away. Okay, when you do like that, it will automatically call toString method. Okay, this is an example. Let's say you have a class called triangle, and in this class there is a method called toString. So basically this is only returning a string, and then you want to run it. Okay, have a main method. Okay, you create an object of this triangle. Okay, and then you print something. Okay, and then you do like this. Shape. This is shape, right? This object name is shape dot toString. When you do this, compiler will go to the toString method and print it. This is toString method, or you can call the object name straight away like that. So it will automatically go and look for toString method. Okay, that's two ways on how to do it. All right. Another example. Okay, we have a class called rectangle shape. Okay, there is a two attributes, length and width, and then there is a constructor here. The first constructor is not accepting any attributes. The second one is accepting two attributes. One is for length and width, and for this constructor, it will call another method which is called set dimension. So it will actually call here, go here, and then it will execute whatever is in this method. And then it has a method called getLength, okay, which return the length, getWidth, double area. So this is a method to compute the area, and then this is a method that to compute the parameter. Okay, the parameter of the rectangle shape. And then there's a method called toString. Okay, this method toString basically combine all of the variable that you have, okay, and convert it to length. So for example, it will print length equal to length. It will take whatever length value plus width plus whatever width value parameter. It will get it from this method parameter. Area, it will get it from area method. Right, so that's the method in the rectangle shape, and it has a method called toString. And then there's another class which is extending a rectangle shape, and the class name is box shape. So it has additional variable which is called height, and then this is the constructor. This constructor is calling super, meaning that it's calling the first constructor of a rectangle shape. The same goes here. It's also called the constructor. And then there's a set dimension also, but this set dimension is slightly different, where it is having additional attribute because it has height. Okay, there's some I think this is more like to set the height and to set the dimension. Okay, it says it give height to h to height. Okay, and then there's a height get method height, and then there's a new variable for area. Okay, so this is actually calling some of the methods from the superclass. Okay, get length, get width, all those are from superclass. And then volume. Volume, this is a method to calculate the volume, and then the toString. toString will have additional variable which is called slightly different. It will call surface area, which we call area, and then volume, we will call volume. Okay, so that's the two classes that you have, and then this one is showing how you can actually call toString, right? So there is a method, two variable, rectangle and ref, which is the type is rectangle shape. The second one is box and box ref. The type is box shape, and then rectangle is actually is pointing to a new rectangle shape object passing to 12 and 4 value, and then it says here rectangle system out the print line rectangle plus rectangle. So you simply call rectangle like that, okay, without putting the toString. Okay, that is allowed. Okay, and then it creates another object called box, so it's passing 3 parameter to the box shape, and then it prints system.out.print line box \n plus box. So this one is actually calling the toString method inside the box class. Okay, so that's the output. Okay, the box is actually having additional data, right, which is surface area and also volume. Alright, now we'll move on to the next item in the slide, which is on polymorphic reference. Okay, when you are using polymorphism again, you will be having many forms. Okay, so there is a situation where there's a term called polymorphic reference, where there is a variable that can refer to different types of object at different points in time. So maybe one time it will actually the type of the variable is the type of the superclass, and then later on it's the object of a subclass and so on. Right? So it's used to develop generic code for variety of application. So this is what it means. For example, we have two classes. Holiday is superclass, Christmas is subclass. But when you create an object. For example, the variable name is day. Day is equal to new Christmas, but the type here is actually from the superclass, right? So another way is polymorphism also allow a single variable to refer to objects from different subclasses. Okay, that is called polymorphic reference. But this subclass, so this is only related when they are having inheritance relationship, okay, among those classes. For example, if cat and dog are subclasses of pet, so this is allowed. So you declare my pet of the type pet. Okay, pet is the superclass. So this variable type is actually from the superclass, which is pet. But then you assign an object which of the type of the subclass. Okay, so that is allowed. But if you do like this, let's say you put my dog, which of type dog, but you assign it to new cat. So dog and cat, they are actually siblings. Okay, they are not related in terms of superclass and subclass, but they are related because they are siblings. So you cannot do this. When you do this, there will be error. Or you do this, cat, my cat equal to pet. So when you do this, there will be error, meaning that this one is the parent superclass, this is the subclass. You are downgrading. This is actually allowed, but you need to do casting in front. Okay, we'll have a look at the example later on. Okay, so there's another example where there are variable defined of that person, which is person 1, person ref, and then part-time employee, which is, I assume this is the subclass of person. There are two variables, employee and employee ref, and then you create an object called person 1, okay, and then employee, which is from the part-time employee. Okay, you're passing the provided attributes, and then suddenly what you do, you assign an employee which type part-time employee to the person. Person here is the superclass. Okay, the object of person ref is treated as the object of the part-time employee. So before this, is actually the type is correct, right? Now you are assigning a type of object from the type of subclass. Okay, so that is allowed. That is allowed. So this happened because in Java, uh, to support polymorphism, there is a concept called late binding, meaning that when the compiler is reaching the code, then it will do the compiling. Okay, so you can define it slightly different, and it can be changed along the way. All right. Let's see its application in the form of an array, whereby when you first declare it, declare the array, the type is student. Okay, and the size is 40. But along the way, when you assign the value inside the index of the array, it is of a variety type, either from it can the item or the data is actually the objects is actually from the type of the subclasses. Okay, so there are, you can do that, right? In an array. So let's say you have an array called roster, and there are 40. Okay, and you can have a variety of object uh, from the subclasses. Okay, that is allowed. Okay, let's say once you have done that, you want to compute the grade. Okay, so how are you going to know that at which index, what is the type of object that you are dealing with? Okay, so maybe let's say the way to compute grades for undergraduate and postgraduates are different. So how are you going to do this? A way of identifying the type of object is to use an operator called instanceOf. Okay, what you can do, modifying that code that you have seen earlier, you have a for loop. Okay, so you do like this: if roster one is the our name of array. Sorry, roster I is the, you look at one by one item in the array, and then you check instance of. Let's say we look at I equal to 0, so it will look at roster 0. We look at the index of the array at index 0. It will check what is the instance of. It will check whether the instance of object in that index 0, is it an undergraduate. If it's true, then you'll do something about it. Maybe in this case, you have counter to count it. Okay, when you do this, you don't have to put dot or anything. You just put a space in between, and this is actually the name of object that you want to check. If you want to check the postgraduate, so you put postgraduate student. So it depends on the object that you want to check. Right. Bringing to this, it will bring it because when you use polymorphic reference, what will be involved with that? There will be a variable that is assigned to a different kind of object, either the subclass object or the subclass object. Okay, so you can what you have seen just now in the earlier example is the form of implicit casting. Okay, where the front type of object is the superclass, the one at the back is actually the subclass object. Okay, I think that is what we have been seen before, but to make it very explicit, but if you want to do it the other way around, like the one that you've seen in example just now, let's say you okay, let's say you declare a variable of type subclass here, and the name of variable is B, and then O is actually of type the superclass. So if you want this to be happen without any error, what you need to do is you need to cast it. You put casting in front. So what you want to say is O is actually an object. The type is superclass. You want it to be in the form of a subclass, which is in our case is student. So you do casting here. Okay? It is always possible to cast an instance of a subclass to a variable of a superclass. Okay? Because an instance of a subclass is always an instance of a superclass. So I think that is what will be using before, right? But the one that comes after that is called downcasting. When casting an instance of superclass, it's actually a superclass, but you want to assign it to a variable of a subclass. You want to assign a superclass variable to a variable of a type of a subclass, which is the other way around. This is called downcasting. Okay, if you want to do that, you need to explicitly casting. You need to put casting in front, else there will be error. For casting to be successful, you must ensure that the object to be casted is in instances of the subclasses. They should be related, either superclass or subclass. Alright, so be careful with downcasting. Downcasting is basically assigning a superclass to a variable of a subclass. Okay, right, for example, like this. Okay, this is okay, right? So you assign a circle object to a variable, which type of a superclass. So there is no problem with that. Okay, and then you have some implementation, and then maybe this object, my object here is an object type, and then you check whether this object instance is type circle. If it's yes, so what you do is this variable my object here, you casting it, okay, to force it to be type circle. Okay, rather if you don't do that, um, you cannot perform downcasting. Okay, you should explicitly put casting in front. Okay, right. Thank you for your attention.